All right, let's take a look at this worksheet. Front page is just all inverse trig derivatives. I've got our inverse trig derivatives here with our derivative with respect to u. I like it so that it shows our u prime or our chain rule for each problem. So let's go ahead and start with number 1. Y equals cosine inverse of negative 5x cubed. I feel like once you practice a few of these, you really get the hang of it. So we've got our formula here. Our u is going to be negative 5x to the third. So the derivative of that is negative 15x squared. But we're also going to put a negative on that. So it's going to be negative 15x squared over square root of 1 minus our u squared. And that's really all there is to it. It's just a matter of, this whole front page is just a matter of following the formulas. But we can do a few more. Now also keep in mind, I am putting parentheses around the of negative 2x squared, just to remind us that there's nothing being multiplied in here. It's the sine inverse of negative 2x squared. So we've got our sine formula here. Our u is negative 2x squared, so u prime is negative 4x over square root of 1 minus u squared. Got our second one done. All right, number 3, y equals tan inverse of 2x to the fourth. Let's take a look. Right there, our u is 2x to the fourth. U prime is 8x cubed over 1 plus u squared.
Daddy, say let me go to Mario.
You want to play Mario, Jax?
Yeah,
Gotta play Mario.
Mario.
Number 4, y equals cosecant inverse of 4x squared. Got our cosecant inverse formula right here. Negative u prime, u would be 4x squared, derivative of that is 8x, negative of that, over the absolute value of u times the square root of u squared minus 1. Got our inverse cosecant derivative. All right, number 5, we start getting into some fun stuff. We have got a function cubed, and the function is sine inverse of 5x squared. We've already done sine inverse. We know how to do all that. So now it's just a matter of throwing a little extra at us. So let's take the derivative of the power first. Y prime equals 3, the whole thing, squared. 3 goes to the front, 3 minus 1, perfect. Now our chain rule problem of the derivative of the inside. Our derivative of sine inverse is right here. Our u value is 5x squared, so u prime is 10x over square root of 1 minus u squared. Leave it like that. Good to go. I really like that we put number 6 next to number 5. Well, that just makes sense. But also, to highlight the subtle differences of the sine inverse of this cubed. So now u is this cubed. Our sine inverse is not cubed like it was in 5. So, same problem as number 2, basically. U is this, so the derivative of that is 3x to the 5th plus 1 squared times its chain rule of 15x to the 4th over, looking here, square root of 1 minus u squared. So we'd actually have this probably to the 6th power if we wanted. Y prime. Cool. 7's a lot like 5. We've got the whole thing squared. So first we've got to take care of our power rule. 2 times cos inverse of 4x squared to the first power. Now times our chain rule. Our chain rule is the inverse cosine derivative. U is 4x squared. So our 8x negative on the top over the square root of 1 minus 4x squared squared. Again, I would just leave it just like that. Maybe clean that guy up right there. Call it good. One more. And finally, we've got one that looks like 6. First, we've got the cosine inverse derivative, and our u is actually, again, this whole thing is u, so its derivative is 3 times negative 2x cubed minus 3 squared times its chain rule of negative 6x squared over, let's put a negative in front of that because that's what the cosine has, over the square root of 1 minus the big U, negative 2x cubed minus 3 cubed squared. Great job on page 1. Now, I would, again, recommend, if we went too fast, go watch it again, turn the video off, try it again by yourself. These are just a matter of plugging into the formula. Totally got this. Great practice with power rule, great practice with chain rule, and then inverse trig. We should be getting all kinds of derivative practice. And then we can start with like real calculus.